Alright, one step closer here. Here's the valves look like that we just ground. So, get this with the camera, we'll see what I did. Camera doesn't want to focus in, but anyway, if you see the first groove right in here, it's about a third of the way up between, about 40% of the way up, then there's a line, then you go 60% more out. So this one above my thumbnail here is the 45-degree seat, and then the right here at my finger here, that is the back cut. Now the back cut takes your valve, and find some background here might help. Yeah, that helps quite a bit. It blends the angle in there so you can see it. It blends a real nice radius going right across your face here. And this will give you a little more horsepower. It makes the heads flow more air. And when it comes to porting and making your motor run, your valve seat's your most important thing, and then everything past that, it gets less critical the further out you go. So right under the valve seat's very critical on this side, and inside the chamber here where you got this lip rod in here, that stuff's critical. It causes problems. That's why multiple valve angles make the motors run so good, because everything right next to that seat matters. So changing these angles here makes a big difference. But I just use traditional 45 degrees. But for racing, 55, 58, 56, 52, there's all kinds of fancy angles they use. 60 degrees on some guys, but that's usually too much. But 55 seems to be a pretty common number these days. But anyway, I just use 45. It's easy. So the both intakes are done the same. You can see the angles are about, the width of the seats are pretty close. So when I go ahead and cut the seats in the head, I got to make sure that my seat sits on this outer edge of the valve, not down here on the inside. And if you have a big valve in here, and if you seat on the inside in here, all of that extra area is wasted space. So all that does is shroud your valve and makes it run slower. So if you're going to put a big valve in it, put the seat out there where it belongs. Otherwise, put the small valve in there, because if you put the seat way on the inside of this valve, like everybody likes doing, then you might as well just put this valve in there. It'll run better with that other valve. So the exhaust is the same thing. See how you got the two different cuts in there, and it makes a difference. Also, what you do on this side of the valve out here, these have a radius out here. That's good for exhaust flow, bad for intake. See on these valves here, it's a sharper edge right here. I don't know if you can see it, but you sure can feel the difference. This one here is a nice radius edge right here where my thumb is at. See how it's shiny in the light? This one here, those are little nicks in the sharp edge, but see how it's got a sharp edge right here? Because you don't want the exhaust intake to flow back, where you want to go this direction, into the motor, not out of the motor. The exhaust is the opposite, it comes into the motor. Comes out of the motor into the port and flows that way. So Kibble makes their valves both ways, so they're made correctly. That's why their valves work better than most people's valves. See, here's a Harley valve. See, they don't do any of that junk. They pretty much have a very light chamfer on that edge, and they do the same thing on this edge. They make them the same. So, and they also don't, they don't do any kind of back angle or any of that other stuff. But that's how race motors are done. Okay, so next thing is we move on to doing our valve guides. These are honed to fit, so that means that new valves don't fit in new guides. We have to fit them. Okay, I have dial bore gauges up here, and these are 7mm stems, and most of these gauges only go down to 5/16. This one goes down to 300 thou, which is in between the two. This one here will go down smaller, but I don't really like the design. This thing's a piece of crap, doesn't work correctly. It's a $500 tool, but it doesn't matter. Works like shit, so I don't use it. I don't like it. Piece of crap. Doesn't matter who made it. So, what I use is basically, I call a plug gauge. Some people call them go, no-go gauges, whatever you want to call them. Basically, this is a solid carbide pilot, and I use it for multiple things. So I use it for setting my valve stems. So this here is where the taper starts. This is straight. Then at this groove it tapers on up to here, and it'll taper about, I think it's about 2.5 thou from there to there. So you measure your stem diameter here with a mic, and let's see if I can show you that. And you figure out your numbers. So this one here, if you read it, see it's halfway between 0 and that next mark, so that's a 1/2 thou over. The intake, see it's almost a full thou over. Before I honed it on the stem, it was a full thou over, so I took off a 1/10 or 2/10 by truing up the stem. See how this one here is closer to the one, so you only cut about 1/10 off, so there's 1/10 and a half difference in two stems. That's common too. Now basically the reason the exhaust valve is smaller, the stem, because see it's back down here, whoop, get it, the light is, there you go, it's just under half, it's about 4/10 down, is because the exhaust have more clearance on the stem than the intake because they run hotter, they swell up more. So like everything, heat expands, so if this is running at 1,000 degrees and this is running at 400 degrees or 300 degrees, it's going to be a different size, so they expand, so you give them a little extra clearance. So this one here roughly run a 1/2 thou more clearance on the exhaust than the intake, and that's what I do here. And Kibble White being good company, they make their valves that way out of the box. Harley valves, the stems are pretty close to the same size, so there's no clearance built in. So you have to make the guides different. They don't, they just make them all loose. So when I hone this, my gauge here, basically, I want to run, you go up a certain distance here, see there's my gauge starts at the size of the exhaust stem, that would be 0 clearance. That's right here, I'm just past the 0 point. This wear mark up here is where I would do my race bike stuff at. See how it's over here at 1.5 up, 1 3/4. Their valves are down about 1/2 over to 0. So that's the number used on the intake. Exhaust, you run looser. I like to run about 1.4 thou on the intake valve for clearance, and I use 1/9 to 2 thousandths on the exhaust valve. So if we have halfway, we need to come up 2 thousandths. So right there is about 2. See, it's halfway, 2.5. So you look at where it's on my taper. So that means when I hone my valve guide right here, I want the valve guide to slip up to it till the point where the indicator's at, which is right there. So about 3/8 of an inch up from the edge here is where my clearance would be correct for the exhaust valve. And the intake being a 1/2 thou tighter, it works out to being about a 1/2 inch down from there. And you see right there, we're about in the right spot for giving me the clearance I wanted, 1.5, 1/4. So I'm going to use this gauge here basically as a go-no gauge. So I'll hone the intakes to about a 1/2 thou from this edge, and the exhaust I'll go about 1/8 inch less. So that makes it pretty accurate. I use 2 grits. I use a coarse and a fine. I'll hone it until this will go in the hole. That'll be my coarse grit. And then the rest I'll do with the fine, which is basically the last thou, 1.5 thou. So preferably about the last thou. So I'll hone these out, and that's how I'm going to do it. So seems to work fairly good. Like I said, these fancy gauges up here, they're not accurate. So if you don't have accuracy, don't use it. Come up with something that works. This here is pretty damn accurate. So I'm going to do it this way. Okay, so I'm going to set this up and go do some honing.